Greetings all. Tonight we're going after the Helix Nebula. But the way we're going after the Helix Nebula is going to be a big surprise to all of y'all, a big pleasant surprise. It's probably more pleasant to me, but hey, I like to share. Let me show you what I'm talking about. Look at this big old telescope. Can you hardly believe that? This big old new telescope. I'm telling you, that's a big telescope. And I'm kind of excited to get first light on it. This is going to be first light on my Celestron Edge HD 11. All right, let me show you some things about this scope. Well, there it is, setting up on the Optron CEM60. And look at my counterweights down here. I had to go and get some more counterweights to put enough weight on there to balance it. And I got to tell you, it is not easy to balance this scope. In the declination axis, you see I had to put these weights on here. I found this thing that just hooks on by a dovetail to the bottom of the bar here, and it only came with one weight, but I bought another weight for it, and that still wasn't enough to get enough weight on it to balance it in the declination axis. So I took a counterweight from my small mount, my Skyguider Pro, and I just kind of sandwiched it in between there, and then that gave me enough counterweight to balance in the declination axis. But it's not easy, I'll tell you that. Now, one thing I'll show you, you see I got my 4 dew heaters up there, which I need to have, but let me show you what else I've got on here. You see that right there? That is a ring, it's a dew heater ring. It just replaces the ring that holds on the corrector plate. But look at there. It's a dew heater ring that goes on, and it puts heat right on the glass. So between my standard dew heaters and this new dew heater ring, I'm hoping that that's going to be enough to keep this big old telescope clear of dew, but time will tell. We'll probably learn that tonight, actually. Now let me show you the rest of it. You see these 2 knobs, this one and this one right here? Those are mirror locks. You just tighten these up, and it prevents the mirror from moving, so you don't get the mirror flop that you sometimes get with the 8SE. And then if you look right around over here, here's the focus knob. I don't have an automatic focuser on it yet, but I'm going to get one. Now, look at this big old image train back here. I had to build a completely new image train for this telescope. It's 2-inch equipment rather than the 1 1/4 that I have on my other scopes. But look at that big old focal reducer right there. Of course, this scope doesn't need a fill flattener because the Edge Optics takes care of that. But this right here is a 0.7 focal reducer, and that thing is heavy. I forgot how much it is, but it's a handful. Now I got to tell you, it took me about 2 weeks to get this image train put together, one that works. And you probably are going, well, how did you do it? What did you use? Well, I'm going to show you, but that'll be a different video. But anyhow, I've got a 2-inch Celestron off-axis guider here. I'm using my Starlight Express Lodestar X2 as the guide camera. I've got a automatic camera rotator on here now. I haven't been able to get it to work yet. I'm still working on that, but it's there, and soon I'll get it to working, so I don't have to do manual rotations. Right behind that, I got this is a 2-inch filter well. It's a ZWO 2-inch 7-position filter well, so I can fit all my LRGB in there, my broadband, and I can fit HA03 and S2 in there. And then finally the ASI 1600mm Pro. But that's the image train, and I got several spacers and adapters and stuff in there to make it all hook together and get to the right spacing. But again, that's a different video. But that's what we're using. The Ioptron CEM60 carrying the big old Celestron Edge HD11 with the 2-inch image train. Now the Helix Nebula is a planetary nebula out in the constellation of Aquarius, about 650 light years from Earth. Now what planetary nebula means, and the Helix Nebula in particular, is it's a dying star. It's a medium-sized star, much like our sun. And the sun, this star is gone into the process of dying, and what it's doing is fluffing off its outer layers of gas and stuff. So when you see the Helix Nebula, what you see is the star that has puffed off its outer layers, and that is what has made the Helix Nebula. And if we can capture this just right, if I can get in close enough on it and get enough detail, then you'll be able to see the dying star in the center of the helix. They call that the progenitor. Anyhow, that's the star that's in the process of blowing up and dying, creating the Helix Nebula. Now the Helix Nebula is one of the closer planetary nebula to Earth. In fact, it's pretty doggone close, so that it appears really big to us. But that's just because of how close it is. But also because of how close it is, it's bright and fairly easy to photograph. Now let me show you, I'm looking back to the southeast here, and you see that tall pine tree right out there? The helix is going to come right out from behind that tall pine tree. It's going to clear that pine tree back in the southeast, and then it's going to arc around the sky to the south. Just like this. It's never going to get very high, and then right here it's going to pass the meridian to the south, and then it's going to come on back down, and it's going to disappear behind the trees right out there. Right about. Okay, here we are ready to get going on the Helix Nebula with the big Celestron Edge HD11, my big new telescope. I'm very excited about this. This is going to be first light on this telescope, so I'm happy to share this project with you. The first light project is the Helix Nebula. So let's see where we are and how we're going to make that happen. It just got polar aligned. We're sitting pointed right up here towards Polaris. Now, I've already showed you what the Helix Nebula is going to look like going across the night sky. Let me show you what it looks like in stellarium. It can be found over here between the southeast and the south. It's kind of right now in between Jupiter and Saturn, and it's up above this bright star called Fomalhaut. It's about right in this area where that red stuff is. So let's zoom in there and see if we can find the Helix Nebula. There it is right there. So let me show you how we're going to get this done. Right now we're pointed up to the North Pole. Just got polar aligned. We're going to go to the star called Vega. It's a big bright star right over here, a little past the meridian. We're going to go there to do our focus. And from there I'm going to go over to the double cluster to do the autoguider calibration. Now let me tell you why. I want a big old bright star to do the focus, so that's why I'm going to use Vega. Now, why am I going to calibrate my autoguider in the double cluster? Well, in short, I don't know. And let me tell you what I found out. I think it might be a weight issue, that maybe this mount that I'm using is barely capable of hauling this telescope and its big old heavy image train, and then the necessary counterweights. I might be right on the ragged edge of what this scope can do. So when the scope gets stretched out horizontally, like it would if it's looking at some object near the meridian, then I think that may be just a little too much inertia for the mount to handle on a routine basis, and so my auto guiding is not as good, and the auto guide calibration is not as good. Whereas if the mount is standing more straight up, so that weight is more down through the center of gravity of the mount, then I think it handles it a whole lot better. And I think that's maybe why my calibration, auto guide or calibration, is better on the double cluster, because at this particular point in time the mount is standing more straight up and down when I'm looking over here than it is stretched out sideways. That may or may not be the reason. The other possibility, there is a whole bunch of really good bright stars right here in the double cluster. So maybe it's just finding a whole bunch of really good stars to look at to do the calibration. So it could be any of those, it could be none, but I found this is when I calibrate the auto guider here in the double cluster, it works better than anywhere else. So that's what we're going to do. After we're calibrated, then we'll swing over to the Helix Nebula over there. And remember, we are not going to rotate the camera after the calibration is done. That's a lesson that I have learned, and I think it's stuck with me this time. So here we go. What we're going to do now, we're going to get going over towards Vega to do our focus. There's Vega. So I'm going to hit the slew button, and when I do, the telescope is going to head over towards Vega. It's going to make its best guess. It's going to try one time to point at it and stop. So let's watch it do that. When I press this slew button, it's going to head on over towards Vega. Here we go. And there it goes. Look at that big old scope. How about that? Look at that big old scope riding on the mount, heading right over towards Vegas. I'm telling you, that thing's pulling in a lot of light. A lot of light. I can't hardly wait to see the picture that it's going to make. So there you go. The scope thinks that it's, and look at that big old image train. That is a big old image train. It's pretty heavy too. Anyhow, the scope thinks it's pointing at Vega. Let's go take a look and see if it is. Yeah, there it is. Pointed right at Vega, so that's good. So now we're going to put on the live view, put on the Batinov mask, and get our focus done. Now I got to tell you, I've got a different Batinov mask. It's what they call a triple Batinov mask. So instead of putting one X on here with the line in the middle, it's going to put a whole bunch of X's on here with lines in the middle. So let me show you what I'm talking about. All right, you see that? You see it's got 1, 2, 3, 4. It's got six of these X patterns on here. So let's zoom in and look at it. Yeah, and you can see that the center spike is off to the side in all of the X's. So we're not quite focused, which is no surprise because I just eyeballed it. So I'm going to go and try to tighten up this focus and get these spikes to get right in the center of these X's. So let's see if we can get that done. Okay, I tell you what, I'm going to call this focused right here. I fooled around with that a whole lot longer than I meant to. It's not as easy as it seems like it might be, but this is about as good as I can do it, and we're going to go with this and call it focused. Okay, calibration is done and it started the guiding. Now look at down here. It started out at 0.85, 0.88, so under a minute. That's pretty good. I'm happy with that. So you see what I mean? That I know that it can guide. It can guide this scope pretty good. So will it be this good when we go to other parts of the sky? I don't know. So I'm going to stop it now, and we're going to go and get on the Helix Nebula. So I'm doing the Helix in hydrogen and oxygen. So you see I'm going hydrogen, oxygen, hydrogen, oxygen. We're doing 10-minute exposure, so we're going to get 4 hours, and that's about all I'm going to get before this target sets. So here we have our Helix Nebula plan called up. So if I've got everything right, as soon as I push the run button, it's going to magically go and get on the Helix Nebula. It's going to start guiding, and it's going to start taking pictures. So let's see if it does all that. Here we go. All right, it's moving. That's a good sign. Oh, that ain't a good sign right there. That is not good right there. I need to go cipher what that is. Okay, a couple things. That bad sounding noise, I had tightened the declination clutch too tight on the mount, and it binded up, so I just had to loosen the declination clutch just a little bit, and then it started moving freely again. Now, the reason it wouldn't plate solve is, you see this awful shadow down here in the corner? Well, that's a tree. It's looking through a tree. I did bad math when I calculated when the helix was going to come up. I thought it was going to be clear of my tree right now, but clearly it is not. So we're going to go on pause for about 10 or 15 minutes, or however long it takes to clear the tree, and then I'll be right back with you to resume the Helix Nebula. All right, right yonder you can see the Helix Nebula. This bigger star right over here is Jupiter. The smaller one that you see right out there, Saturn. And then if you look down in my tree, kind of right in between the goalposts there, you see the star Fomalhaut. So I think the Helix Nebula just cleared that tree. We're going to give it another try. Okay, here we go, ready to get going on the Helix Nebula after the unfortunate tree incident. So if I push this button, everything's right, and it's clear the tree, then it's going to magically center on the helix, and it's going to start guiding, and it's going to start taking pictures. So here we go. Let's see if that happens. Okay, it thinks it's on the helix, so it's going to take a picture. Here goes the 5-second picture. Once that comes in, it's going to plate solve it. Watch it right down here. And it believes it's in the right spot because it's starting guiding. And if you look up here in the plate solve picture, you can actually see the helix right here. Let's go back to imaging. So here goes the guiding. The guiding is going. And you can see it's taking our first HA picture now. But let's go back to the imaging tab. And here is the 5-second plate solve picture that it took. And you can see right here is the Helix Nebula, right there. So we know that it went to the right spot, because there it is. So it's off and running, it's guiding, taking pictures. And I'm going to be back with you when the first HA picture comes in to look at it. And again, this will be first light on the HD11. Alright, here we are, about 5 seconds for the first HA image to come in. Let's watch it come in together right about now. There it is, the Helix Nebula. How about that? How about that? That's some pretty good detail right there. Look at that. Looks just like the helix. I got to tell you, I'm pretty happy about this. So it's off and running. I like what I see. And I tell you what, I'm going to let it run. So it's going to take about an hour until it finishes with these HAs, and then it'll start taking some O3s. And I will come back with you to take a peek at the first O3 when it comes in. All right, here we go, about 5 seconds until the first O3 frame comes in. Let's watch it come in together right about now. First O3. Here it is. How about that? How about that? There's a lot of O3 signal there. A lot of good signal. I got to tell you, again, I'm pleased with the O3 frame. You got 6 good HA frames. O3 frame looks pretty good. Now I will say that I did have some clouds roll through near the end of my HA frame, so had to pause the program for about 20 minutes. That's why it's a little later than I thought getting back to it. But we just crossed the meridian on the other side of the meridian. Got our first O3 frame, and it's looking good for the rest of the night. And I'll tell you what, I think overall that I'm pleased with the first light on the Edge HD11. And unless anything strange or weird comes up, then I will see you at the end.